All right, so we want to draw the most stable conformation of 3-methylpentane by looking down the carbon-2, carbon-3 bond. So step one, you want to start off by drawing a nice little zigzag drawing here of the starting structure. So 1, 2, 3, 4, 5 is pentane. And then we want to position a methyl group at carbon-3. Okay, so that right there would be the starting point for our drawing. Now, you want to number the carbons. Okay, and we're going to be looking down the C2, C3 bond. So that's the direction we're looking. Now, step two is to number the carbons, right? Step three is to add wedges and dashes to carbon-2 and carbon-3, those two carbons that we're interested in. Carbon-2 has two hydrogens that are not drawn, so we want to draw a wedge and a dash. And carbon-3 has this methyl group there. So we want to position that using a wedge or a dash since it's just drawn as a line. And it doesn't matter which way we do that. When you get to the next chapter, stereochemistry, you'll see that this molecule is achiral, and either way is equivalent. I'm going to choose to draw this as a wedge. So let's make our methyl group coming out towards us. Remember, the carbon-3 is sp3 hybridized, or tetrahedral, so it has shape to it. So step 4 is going to be that we want to draw, abbreviate some things. So this guy coming right here, carbon-1, so don't abbreviate anything on carbon-2 or carbon-3, but off of carbon-2 is a methyl group, and off of carbon-3 is an ethyl group. So this is getting kind of messy, but I'll draw it over here. Now I'm drawing in my C's for you there so you can kind of see the carbons a little bit better. So what we're basically doing is creating our own wedge dash drawing for this molecule that shows very clearly the three-dimensional directions of the groups attached to carbons 2 and 3. We're abbreviating all the other stuff so that we don't really worry about the wedges and dashes on those, okay? And now we want to look down that bond, okay? So now we produce the Newman projection, okay? So let's go ahead and do that. For the Newman projection, the front carbon is going to be a dot and the back carbon is going to be a circle, okay? And so let's go ahead and draw what we have. So on carbon-2, that's the coming off the dot, we have a methyl group pointing down. And if you look down that bond, if you need to make a model, that's fine. You have two hydrogens coming off to the top left and top right, okay? And that's carbon-2, which is my dot, right? The back carbon is represented by the open circle, and we draw bonds coming to that open circle. So going up in the back is this ethyl group, and to the right, coming out of the board in this representation, if we look down that bond, it's going to the right, it's a CH3 group, okay, and then to the left is a hydrogen, okay. So this conformation here is the lowest conformation. That's the most stable because the largest groups on the back carbon and the front carbon are opposite each other. Now I do know you have this gauche interaction here, but that cannot be avoided in this lowest energy conformation. Okay, so this would be labeled as the lowest or the most stable. Okay, so there's a lot of steps there to